Hello dear, today we will solve exercise 1, page 20. Let's look first at the figure. I have segment AB and 3 lines U, V and W that are perpendicular to this segment at different points. Let's start. Answer by true or false. U is the perpendicular bisector of AM. This is U, line U and segment AM. I know that perpendicular bisector is perpendicular to the segment at its midpoint. Since given that AE equal to EM, that means E is the midpoint of AM. The first condition is correct. The other condition, U perpendicular to AB. Then yes, U is perpendicular to AM at its midpoint E. So the first expression is true. Next one. V is the perpendicular bisector of AF. V is perpendicular to segment AF. But can we say that M is the midpoint of AF? No, it's not. It's given that EM equals to MF. Then M is the midpoint of EF. Why I'm talking about M? Since V is perpendicular to this segment at M. So V is perpendicular bisector of EF since it's perpendicular at the midpoint M, and it's not a perpendicular bisector of AF. So it's not AF, it's EF, and the expression is false and not true. If G is a point of W, you can write it anywhere here, above or below. I will choose this point, G. Then GM equals to GB. Is this expression correct? One of the properties that we studied is any point on the perpendicular bisector is equidistant from both extremities of the segment. W is perpendicular bisector of MB since W is perpendicular to MB at its midpoint F. Then any point on the W, for example G, is equidistant, having the same distances from M and B. So yes, GM equal to GB, and this expression is true. A circle of center E cuts U in 2 points K and H. I have to draw a circle of center E. It cuts U at 2 points. This is point K and this is point H. They told me that BF, this line, is perpendicular bisector to KH. According to definition, the perpendicular bisector is perpendicular to the segment at its midpoint. Here we have BF or BA, the line is perpendicular to KH at point E. The second condition is E, a midpoint of KH, to say that it's perpendicular at its midpoint. EK is a radius of the circle. EH is another radius of the circle, and we know that radii of the same circle are equal to each other. So yes, KE equal to EH, E is the midpoint of KH, and BF is perpendicular to KH at its midpoint. This expression is true. Now V is the perpendicular bisector of AB. This is V. Perpendicular, yes, it's perpendicular to AB at M, but can we say that M is midpoint of AB? Here we have EM equal to EA and MF equal to FB. Both segments here are equal. I have AM equal to MB, M is the midpoint of AB, and V is perpendicular bisector of AB at its midpoint M, so this expression is also true.